Greetings, everyone. For those of you who don't know me, my name is Chris Morissette. I'm the Thomas Chairman for HAS. I'd like to welcome you all to tonight's August Novice meeting. We have a guest speaker today, Mr. Will Sager, and he will be talking about meteor observing and photography. So just kind of a brief intro for Will. Few things in astronomy are as immediate and enjoyable as watching a bright Perseids fly down the Milky Way. Perhaps you want to watch some meteors yourself. Well, how do you watch a meteor shower? Perhaps you want to make observations to help meteor astronomers understand this phenomenon better. Maybe you want to take a picture of a meteor. I have tried and I have failed, so I'm looking forward to this talk. Will talk about meteors, meteor showers, and how to observe and photograph them. A little bit about Will himself. He is a professor of geophysics in the Department of Earth and Atmospheric Sciences at U of H. He has been an amateur astronomer for many years and was inspired in part by the 1966 Leonid meteor shower, which he didn't see because he was a boy living in the city and didn't know how to see it. He began regular meteor observations after joining the Meteor Group of the Hawaiian Astronomical Society while in grad school in the 1970s, and has continued to make meteor observations since. So with that, I want to turn the floor over to Mr. Will Sager. And Will, you can go ahead and share your screen.
Okay. Hello, everyone.
While Will is presenting tonight, if you have any questions, put those in the chat, and then we will come back later at the end of the presentation, and I'll go through the questions, and we'll have Will answer any questions that come up in the chat. So with that, Will, go ahead and take it away.
All right. Thanks, Chris. Hi, everybody. Thanks for coming. A lot of astronomy is pretty static, right? You look at a galaxy today and look at it in 50 years, it'll probably look the same. I like astronomy that does stuff. And so that's one of the things that really got my interest in meteor observing. And you probably would like it too. If you haven't done it and you want to give it a try, I want to try to give you a few pointers. So meteor watching is easy. It doesn't take much equipment, basically just your eyeballs. You just got to go to where you can see the meteors. And so I want to try to do in this presentation is tell you a little bit about what are meteors, how are they related to meteorites, when can you see them, what's a meteor shower, what's a meteor storm, and how do you observe them, what equipment do you use, and everybody wants to take pictures nowadays. So I'll try to talk a little bit about pictures at near the end here. Okay, so why do I observe them? Well, I think they're fun. Occasionally it has me yelling at the night sky. That's good, yelling in a good way. Not get off my lawn. You only need simple equipment. Once you get there, you got to get up in the middle of the night to do it. Got to go someplace dark. But once you do that, you pretty much just go. It's also a chance to record data that does help astronomers who study meteors. I'll talk about that a little bit. So what are meteors? The meteors are streaks in the upper atmosphere caused by the collision of space debris with molecules in the upper atmosphere at high speed. So some little chunk of space debris flying around in space is called a meteoroid. When it streaks across the sky, we call it a meteor. And if it lands on the ground, we call it a meteorite. But most meteoroids never get through the atmosphere. They're burned up as they heat up in the atmosphere. So here's a proof that meteors are hitting the upper atmosphere. This is a view from the International Space Station, and there is a meteor out there. That's the Earth's atmosphere. So it is below the space station, streaking through the atmosphere. So where do meteors occur and how do they occur? As I said, they come flying in at high speed. The speeds are like 11 to 72 kilometers per second. Think about that for a second, really fast. And they hit the upper atmosphere And typically it's in a range of 50 to 100 kilometers. So here's a kilometer scale over here, stratosphere, troposphere. They're way up here in the mesosphere because they're going so fast that even the very thin atmosphere up there causes them to go incandescent. So this is happening right now, just that right now it's daylight and you can't see much of anything. It's estimated that 15,000 tons of meteoroids hit the atmosphere each year. And when the meteoroid hits the upper atmosphere, friction causes it to heat up. And the streak that you see is caused by the meteoroid glowing incandescent and also the ionization of upper atmosphere molecules as it whacks into them. Now, most meteors are vaporized in the atmosphere. Some of them decelerate and survive their plunge, and they land on the Earth. And maybe you've even found one of them at some point. So what is it you see? Well, you see something like this picture over here. This is a streak of a meteor. It's a photograph, obviously. Usually this streak happens in a fraction of a second, say a half a second or so, sometimes several seconds. Often the streak is short, maybe just a few degrees. Sometimes this one looks like it's maybe 30 degrees long, something like that. Sometimes they're that kind of length. Rarely are they longer, but sometimes. Usually they start dim like you see up here, and they finish bright and then flame out, sometimes with a little bit of a flash. Some meteors appear to be going up, some appear to be going sideways, some appear to be going down. It all just depends on the angle it approaches the Earth and the angle that you're looking at it. A few are as bright as the brightest planets, but most are dimmer. So they're like stars. Many of them get down to the brightness of dim stars. So just like the stars, if you have light, you're not going to see them. Light pollution wipes them out. So what is a meteor shower? Well, a meteor shower occurs when the Earth goes across a stream of meteors, typically meteoroids. Meteoroids are spalled off by comets, and they end up in the orbit of the comet. And when the Earth crosses the orbit of the comet, it will hit the meteoroids, and then we see a meteor shower. Sometimes the meteoroid stream is compact near the comet. Sometimes for an older comet, it's spread out all along the path. So for example, like the Perseid shower is pretty regular, so its debris is pretty well evenly distributed. But other showers have peaks and troughs where sometimes they're better than others. Now, if you just go out tonight, well, tonight's probably not a good choice because we're ramping up to the Perseids. But on an average night, you might see maybe 5 an hour from a dark site if you look carefully. But there are some dates when we see many more in a single night. Usually those are called meteor showers. And they happen because the Earth happens to be crossing that debris. Now, there's debris out there, and those random, what we call sporadic meteors, they're just debris out there that the Earth happens to intersect as it's flying around in its orbit. So when we see meteor showers, they typically come from what we call a radiant. They appear to emanate from a point, just like this diagram B right here. The meteors appear to be going in all directions outward from that radiant point, but they're actually, like in diagram A over here, they're all coming more or less parallel as the Earth moves into the stream. But what we're seeing is a perspective effect. So here's an observer's eye down here, and a meteor over here will be going in this direction, and it'll be a little bit longer. Over on this side will be going in another direction, and they appear to go back towards the radiant. It's a perspective effect. Hey, how are you? And so, because I know that many of you have seen a snowstorm, this is a radiant. When you're traveling in your car into a snowstorm, the headlights light up the snowflakes, and the snowflakes go streaming past you. So they're just like meteors coming from the radiant. If you haven't, I suppose if you haven't been in the snow, maybe you can find a dust storm or go north. Here is a photo from the 2023 Perseid shower. The radiant is in here somewhere, and these are meteors that were recorded. This is not a single exposure, by the way. And you can see that on this side, they're going this way, Down here, they're going that way. Over here, they're going that way. And if we trace them back, they end up somewhere in here where the radiant is located. And here's a warning. I'll say this warning again. You got to watch the media. The media only cares about clicks. This is a fake picture that I found online with ABC News, no less. This looks like a zoom effect. I think that's the wrong part of the Milky Way. And you can see the meteors are too regular and they start with a dot and they end with a dot. I think somebody just played around with their zoom lens for this. So caveat emptor. There's a lot of news stories out about meteor showers. A lot of the stuff is wrong. So know your sources and look for the good stuff. So as I said, radiants are in different constellations. The Perseid shower radiates from the border between Perseus and Cassiopeia. So here's the constellation Perseus down here. Here's the constellation Cassiopeia up here. And the radiant is up here in between. And so you don't necessarily want to watch the radiant, because remember, the meteors are foreshortened in that place. Probably around 60 to 90 degrees away is a good place, because now you're seeing the meteors at a better angle. But if you see this meteor over here and you trace its tail back to the radiant, and the radiant is in Perseus, then it's a Perseid. Here's a photo from the Geminid meteor shower. That's another really good one. It occurs in December. And here is Castor and Pollux. So that's Gemini up here. You can see the meteors tracing back to that point right there. So not all meteor showers are the same. I mentioned two really good ones, the Perseid shower and the Geminid shower. But there are a couple of dozen meteor showers, and many of them are minor. So you're not going to get a whole lot of meteors out of them. Doesn't mean it's not worthwhile to go out and look. It's just you're probably not going to see very many in an hour. You might get a little bored. As I mentioned, the two regular showcases, the Perseids, which usually peak around 12th to 13th August, and the Geminids, which peak 13 to 14 December, and they have high rates, about 100 per hour. So let me stop it with that rate and say what that means. Typically, the rate depends on your sky, the altitude of the radiant, your weather, and so usually a rate is given that's called ZHR, zenithal hourly rate, and it is sort of theoretical maximum that you would see if you're in a perfectly dark sky looking straight up, so that your maximum vision is engaged. You might see 100 an hour. Typically, with the Perseids, it has a ZHR of about 100. But if I see 60 to 70 in an hour, that's a good hour. So the Perseids and the Geminids are around 100. Geminids a little higher. The Quadrantses occur in early January. They have a high rate but a very brief peak. So you have to be on the right part of the Earth that hits the stream. There are a handful of second-tier showers. The Eta Aquarids in May are like a ZHR of 40. The Orionids in October are ZHR of 20. And there are many third-tier showers that have lower ZHRs. One nice thing about right now in the summer is that there's the Perseids, but there's also a couple of minor showers that can add to the display. So a meteor shower doesn't all just happen at once. It has a curve like this. The vertical axis is the zenithal hourly rate, the number of meteors, and the horizontal axis is the day. These are one-day tick marks here. So this is the Perseids from 2016, the predicted rate. And so here's a sharp peak that is maybe several hours in width, but a broad peak that is maybe most of a day in width. That's around 100. But also notice that for a day on either side, you can see a pretty good rate, 40 to 60. And even going out several days in advance and several days after, you can still see the good number of Perseids. In fact, if you go out right now tonight and you look, you will probably see a few Perseids each hour because the shower is ramping up. But if you want to see the most, you want to be around the peak. Here are some meteor rate curves that I retrieved from the internet. This is the Perseids from last year. This is the Geminids from last year and the Orionids from last year. Again, this is the ZHR, the rate on this axis. This is solar longitude, but here's the dates up here. So this is 8th August, that's 15th August. So that's a week right there. And you can see the Perseids having this long ramp up over a couple of weeks' time, and then having a sharp peak for about a day, and then declining over several days and back down to the background rate. Similar thing happening with the Geminids. That's one day right there. So the Geminid peak is a little bit sharper. It ramps up a little bit quickly and ramps down a little bit more quickly. The Orionids are relatively broad shower, so the peak is a couple of days, like a week. There's 21st October, 29th October, and it looks like there might even be some structure in here. So there might be secondary peaks. What that means is the meteoroid stream is clumpy and the Earth goes through a stream and it's denser here and less dense there. So you may get higher rates at certain times. I put in this list. I'm not going to belabor it too much, but these are the major showers. I've mentioned some of these already: the Quadrantids, the Perseids, the Geminids. Here's the where's the ZHR here? Here's the ZHR. Quadrantids are 120, Perseids 100, Geminids 120. Lyrids are variable. They're generally below 20, but sometimes have outbursts. The 80 Aquarids is a pretty good shower. It peaks in early May. Southern Delta Aquarids, it's not a real big shower, but it has a broad peak. It peaks on July 30th, and we'll see some Delta Aquarids now, but you can also see them during the Perseid shower. In fact, because of several overlapping minor showers, when the Perseids are mooned out, I'll go observe around this time, around the end of July, the first part of August, and I'll see Eta Aquarids, I'll see some early Perseids, and I'll also see, these are some minor showers. Now here the ZHRs are all pretty small, under 10, but as I was mentioning, the minor showers in their July Pegasids, you might see a few of those. The Alpha Capricornids is a really interesting shower. It peaks on July 31st. It has a low ZHR, only 4. So if you go out, you're not going to see many. And even on a Perseid night, because it's such a broad shower, you might see 1 or 2 an hour, but they tend to be bright fireballs. A fireball is a very bright meteor. Often it has bursts or maybe sprinkles, I'll call them, as that fall off. And they're often bright green and yellow. So when you see an Alpha Cap, that's really a pretty good thing. You might see a few Kappa Cygnids at this time of year. So it's still a pretty good time. There's a bunch of summer showers that mean almost any given night is a good night to go watch. All right, so I'd like to talk a little bit about meteor storms. And as Chris mentioned, a meteor storm kind of got me interested in this in astronomy as a kid. So when I was a boy in 1966, when one of the Leonid meteor storms occurred. Now, I had heard about it because I was already interested in astronomy, and I looked at textbooks and they had pictures like this picture. So this is an illustration from the late 1800s, and it supposedly depicts the 1833 shower called the Nights the Stars Fell. It was widely seen across North America. And I've got this quote. I thought it was really pretty good. It's from a church elder, Parley Pratt from Missouri. About 2 o'clock the next morning, we were called up by the cry of signs in the heavens. We arose, and to our great astonishment, all the firmament seemed enveloped in splendid fireworks, as if every star in the broad expanses had been hurled from its course and sent lawless through the wilds of the ether. Thousands of bright meteors were shooting through space in every direction, with long trains of light following their course. This lasted for several hours and was only closed by the dawn of the rising sun. Every heart was filled with joy at this majestic display of signs and wonders. So he's obviously writes poetry in his spare time, or did. And not everyone was totally thrilled with this. As I said, there are a lot of reports that the world was ending. The estimates were that people were seeing 10,000 to 100,000 meteors per hour. But the storm raised interest in meteors and got people more interested in what are these things and where do they come from. So here is a more fanciful illustration of meteors from the 1860s. So meteors don't typically do right angle bends. Sometimes you get a little bit of a wobble. Probably the meteoroid is asymmetric, and they don't typically turn around like that. Anyway, so the Leonid shower produces the most reliable storms with outbursts every 33 years. With the 1868 storm, the shower was associated with the comet Tempel-Tuttle. That was just when the idea started coming in that it's comet debris. But the 1899 storm failed to materialize, and 1933 was kind of a fizzle. But then in 1966, there was a strong storm occurred, and people in the U.S. were lucky this time, and it occurred over the western U.S. with a lot of people seeing it at peak where they estimated 40 per second. So by 1999, astrophysicists were able to predict when the Earth would cross the dense meteoroid stream, so we have better predictions. And I'll talk a little bit about more of those in a minute. But anyway, I told you about my story. I think that starts with the next slide. Okay. Well, maybe I get ahead of myself. So in 1966, I was a kid, and my uncle told me about it. And so I remember looking out my bedroom window. What could I see before I went to bed? It was a school night, because of course it was. And I lived in the city, so there were street lights, because of course there were. And I didn't see anything. So I went to bed, just like everybody does, right? Everybody hears the news, they look out through the street lights, they don't see anything, they go, they don't know what they're talking about. Anyway, then I got ahead of myself. There are other storms. This is a graphic from a Larousse Encyclopedia of Astronomy of the Draconids, or sometimes called Jacobinids, that produced major storms in the 30s and the 40s. And other storms can occur without warning. And there are many false alarms in the media. Every so often, every few years, the media will come up, astronomers think there may be a meteor storm. Usually it's not much happens. So what factors affect the meteors? I've already mentioned some of them, and you're in the astronomy club, so you know already. Light pollution is a killer. live here in the center of Houston. I'm not going to see anything from the center of Houston. I'm going to go out to the dark site, which is out there. And so you need to get out in the dark, because light pollution, and that includes this celestial orb over here, will wipe out a lot of the meteors. You'll only see the bright ones. Also, you need to have a clear sky, obviously. Also, sky transparency. So if you went observing tonight with the Saharan dust, you would see less meteors, because the dimmer ones would be masked. The time of night also counts, because you want to be on the side of the Earth that's crashing into the meteors. I'll show you that in a moment. So you probably already know about it, but if you don't, you can look at cleardarksky.com on the web, and you can look at various places. And Texas has a clear sky chart for Columbus, and it will tell you for a few days ahead of time what the cloud cover is like. Blue is good. What the transparency is like. Blue is good, but it's not good here. And of course, it also tells you seeing, which is the scintillation of the atmosphere. That's not really such a big thing for meteors, but this is a way to plan where you're going to go. And so why does the time of night matter? So here's the Earth, and it's flying through space in its orbit like this. And the meteors are out here flying through space, and the Earth comes flying and hits, a lot of flying going on here. The Earth hits the meteors. And so it hits most meteors on the leading edge. But since the sun's over here, that leading edge is right at sunrise. If we're on the sunset side, a meteor has to catch up with us, right? The meteoroid has to have a velocity that's catching up to the Earth. So you're not going to see that many shower meteors. you will see occasional meteors. And somewhere in between, the shower starts to pick up because the radiant's going to be over here. And as the Earth rotates, you'll gradually go around. The radiant will get up in the sky. You'll start to see more meteors until sunrise turns it off for you. So the best time to observe is typically around 2 to 4 in the morning. But it depends on the shower. The Geminid shower gets up a little earlier, so you can go out at midnight and see a lot of meteors. Anyway, so you want to see meteors? Go someplace dark. Try to avoid the clouds and get good transparency. Try to make sure the moon is not up, and get up in the middle of the night. And maybe you'll be lucky and you'll see this is a little GIF I found of a Leonid fireball. So what do you need? Okay, so as I said, it's simple. You required eyeballs, okay? And that's it. You can stand there if you want. You can just look. Not very comfortable. In the summer, you might want bug spray. You might want a comfortable chair to sit in. I like a chair that I can recline almost completely so I can look up at the sky and I don't have much of the sky blocked by the horizon. I record meteors, so maybe you want to record them. That means you need some sort of medium to record them. I use a little voice recorder. You almost certainly want a red flashlight because you want your eyes to be dark adapted, so you don't want a white light. Maybe you want coffee and snacks because you're going to stay up all night. And if you're lucky, you might see something like this Leonid meteor over there. So get comfortable in your chair, get your recording timing apparatus working. I carry around a little star chart that has magnitudes printed on it so I can look up and remind myself that, all right, so Vega is that brightness, and Aquila over there, Altair is that brightness, and so forth and so on. That calibrates my eyes to see the meteors. So I check the magnitudes. I figure out where my radiant points are relative to where I'm looking. So I know when I see a meteor fly in from out of my peripheral vision, I'll know where it's coming from. And as I said, you want to set your gaze upward because you don't want to see the ground. You want to see the sky and you want to see meteors. And so you don't want anything blocked. So you want to go upward, and you're going to see meteors with your peripheral vision. So you want to engage your peripheral vision. So you want to let your eyes sort of slowly wander around the stars and not lock on to a particular star, because then your attention is focused. And then you might record the meteors. You might record the weather, because if the clouds come in and you don't have any meteors, then that's a hole in your record, and you want to know that. And you want to stay awake and have some fun. So as I said, think about where you're looking. So here's a fisheye view. If you look straight up, you can't really see all the way to the horizon on all sides, but you can get pretty far out there with your peripheral vision. So you will see meteors as a flash in your peripheral vision. That counts as a meteor you saw because they occur randomly across the sky. Some will be right in front of you, and some will be somewhere in between, and some will be way off to the side. So you want to pick an area where you don't have many trees to get in your way because they're blocking meteors. You don't have many lights. This looks like it was taken at a star party because I see lots of red lights. And you don't want white lights, and especially bright lights like street lights, because they will make it hard for you to see. And many meteors will be either at the edge of your vision, or certainly as you look down there, there'll be a bright flash from behind you, and you know that you missed one back there. So how do you record meteors? Well, here's the simplest way. Take a little notebook like this, get a pen, take your red flashlight, write down the beginning time and the ending time, put one page for your Perseid meteors, another page for your other meteors, and every time you see a meteor, you don't even look down, just take your pen and make a mark. And then later on, you can go back and count up the marks, and you know how many meteors you saw. And if you want to try to distinguish between different meteors, like I said, these are Perseids over here, these are not Perseids over there. And so that's one way to do it. And so, as Chris mentioned, I've been observing for many years. I use the American Meteor Society format. So, this is just from my Excel spreadsheet. And no, I'm not logging into an Excel spreadsheet. I do this with a hand recorder. And so I record the time. I have a little clock that I got from Radio Shack. Maybe you remember Radio Shack, and it has a voice. If I whack it on the top, it will tell me the time. So I see a meteor, I get the time, and then I estimate this is the magnitude. I estimate how long it took in seconds. So this one took half a second, that one took a second. I estimate how long it is using my fingers. And so I estimated 14 degrees for that one, 5 degrees for that one, 35 plus for that one. That was a -4 fireball. So that was definitely, I was yelling when I saw that one. This is the train column over here. So if it leaves a persistent train, I'll log that. This is a 1 second train, 2 second train. So often the bright meteors have a train, but sometimes they don't. This is the shower. These are Perseids, PER, SP is sporadic, DAQ is Delta Aquarid. And then over here is peripheral data. One of these is distance from central vision. In other words, how close was it to where I was looking? If it's way off to the side, I didn't see it very well. And then I also log the altitude. And then I log how good is my observation? Is it poor, fair, or good? And then I note things like here's one said they're distracted by others at the same time. There were too many meteors all at 8:24, like 5 or 6 at the same time. By that time, I'm starting to forget what they look like. And sometimes I see clouds and I log them. And then this is why I watch. This is from a log from a long time ago. It was 3:19 in the morning, 8:19 UT, -6 Alpha Capricornid fireball, 4 seconds duration, length 40 seconds. Beautiful, slow Alpha Cap fireball. Started with DCV equals 40, but had time to turn and watch most. Electric green color with yellow core. Spalled off yellow fragments in last 10 degrees of flight. Started near Deneb, ended between the Dipper, the Little Dipper, and the head of Draco. I guarantee I was yelling at the top of my lungs. Okay, so I was telling you about my Leonid storm story. So I told you at the beginning. My uncle told me to look for it. I lived in town, didn't know what I was doing, looked out the window, didn't see anything. Unfortunately, this is the experience of most of the public. Can't tell you how many times I've gone to a place where I'm observing meteors and I'm seeing them, but then someone rambles out of their cottage or their bunk, and they, with their flashlight, they look around in the sky for a couple of minutes and they don't see anything, and they walk back in with their flashlight. They never give themselves time to get dark adapted. And I think, unfortunately, the media tends to make that people think that this is what they're going to see. You're not going to see that unless you're really, really lucky and there's a storm one day. So you need to be in the right place at the right time with your eyes dark adapted without light pollution. So as I told you, I missed 1966, but I knew 1999 was coming up. And so I was watching the Leonid shower. And what would happen? So 1995 to 97, the rates started to go up a little bit. So obviously they were starting to get towards the meteor clumps. They were markedly higher, but not spectacular. In 1998, the Leonid shower had a higher rates and a surprisingly large number of fireballs. And here's my story. I drove up to Brenham to observe with a friend of mine who's a meteor observer. And all along the way, I'm seeing one of these bright streaks as I'm driving along. This is driving along the highway with my headlights. So I'm really psyched. And I get there to Brenham and we put out our chairs and the fog rolled in. So unfortunately, this is a common problem with South Texas cold fronts, right? It was clear because a cold front came through, but that meant it dropped a lot of rain and then it got cold. And so the fog came in. I don't know what to tell you except West Texas is drier. All right, so the 99 shower excitement was building, but by now astronomers were starting to be able to do better predictions. Prediction was that the max was going to be over the Europe and the Middle East. Now, I didn't pay for the plane ticket, so I drove out to Prude Ranch and I watched from the upper field. My max hourly count was about 64 per hour, which is pretty good. It's like a decent Perseid shower, but certainly not spectacular. In the Mideast, they reported rates of up to 1,500 to 3,000 per hour. So darn it, I probably should have paid for the plane ticket. So it was a good storm, but it wasn't in 1966. Well, 2000 rolled around and I was getting messages saying, well, we might have a high rate, but, the weather was bad and it was a full moon. So the moonlight hampered observations. And so I didn't actually even get out there to see it because of the weather and the moon. But then 2001 rolled around, and I started getting messages that there might be a storm this year. Like, well, what is 2001? And so astronomers were predicting. So here is a graphic predicting this is the Earth's orbit. Here's the Earth's position on November 17th, 18th, and 19th. And these are clusters of meteoroids that were pulled off the comet's tail by gravitational perturbations. And in 2001, we're going to go through two of them, one peak predicted for North America and one for Asia. And it's like, oh boy, another chance. And so I'm all set to go back out to West Texas. And what happens? Bad weather. A cutoff low settled into West Texas. So there was a low pressure system sitting over West Texas, clouding everything out. So what to do? Well, by then we had the interweb. I jumped on the web and I bought a plane ticket to Phoenix, Arizona. And because I found this place online called Skywatchers Inn in Benson, Arizona. It's maybe 30 miles from it's maybe about 2 hours from Phoenix, 30 miles from Tucson. It used to be open to the public, sadly, not anymore. It used to be a B&B, an astronomical B&B. So they have an observatory out there, and they have nice sky. Anyway, so here I am in 2001, waiting on the sky deck for nightfall. So in the early evening, of course, everybody is too excited to go to sleep. And so we're observing space fuzzies to pass the time. And every now and again, we see one of these things, a fiery javelin of light streak across the sky. It's what's called an Earth grazer. It is a meteoroid that just grazed the Earth's atmosphere. And because it's doing that, it's making a long path. And we get to see it early in the evening. And so the first signs of things to come. By 1 a.m., we're starting to cook a little bit. And 1 to 2 a.m., I got recorded 43 Leonids. Not a lot, but that's not bad. It's almost as good as 99. Here's a photo of a Leonid fireball. Then later, after midnight, the lion starts to roar. 2 to 3 a.m., I recorded 216 Leonids. 3 to 4 a.m., 547 Leonids. So whoopee, things are going like crazy. People are getting photos like this and like this. So you can hear the crowd cheering. Everyone is glued to to the sky. Back then, I still was shooting high-speed ectochrome in film, so it's not really high speed by modern standards. This is the best photo I got. The purple circles show meteors, so I got 10 in this 30-second exposure. There's the circle of Leo. So I could probably do equally as well, a lot better probably with my modern DSLR. Here's another photo of a Leonid fireball with a flare at the end. This is from the 2001 shower. And by dawn's early light, we're still hanging on to the last few as the sky brightens. Venus is a dazzling morning star. Nobody can bear to look down or walk to their car. People are starting to get into clusters and rehash the meteor frenzy. Even at 5 to 6 a.m., I got 374 Leonids in my log. So that was super. That is the best shower I've ever seen. I tried to go back for another bite at the apple in 2002. Another good max was predicted, but a full moon. But I went back to Arizona anyway. I got 260 in 3 hours. It's not bad. Nothing to sneeze at, but not quite the big storm again. Okay, so you've seen a lot of pictures of meteors. So how do you do that? How do you get this? Well, this is a lot of luck. This is more common down here. So you want to take a camera, set it up at least on a tripod so it's stable to take a time exposure. You need to focus on infinity because your automatic camera is not going to be able to focus on the sky at night. So you're going to have to set it at infinity and then take a time exposure. Depending on the ISO you use, you need to figure out when is your sky going to saturate. Modern smartphones will saturate in a few seconds, so they're really ramped up the ISO. I'm typically using like 1,000 to 4,000, and I can get a 20 to 30-second exposure. And then you just hope for good luck. You hope that a big bright one streaks through your sky, but it doesn't often happen. So anyway, I want to mention focusing. I use a DSLR, and how do I get focused on infinity? So I set it up on the tripod. I put live view, so I'm looking through the screen, and I zoom in as far as I can go. I think it's 10 power on my Nikon, and I put it on a bright star. And if it's not in focus, it'll be a blob, and I turn the focus to get as small a pinpoint as possible. And sometimes when you do that, you'll see when it's really in focus, you'll see the dimmer stars come out. And then I put a piece of tape on my lens so I can't turn it accidentally. So there are some things to consider. Most meteors are faint. You need a fast ISO, and even then you're only going to catch the really bright ones. But a high ISO also makes noisy pictures, and the sky brightness limits your exposures. But if you're not really an aficionado, I wouldn't worry about it. Just take pictures. Meteors occur randomly, so you need a wide angle lens to have more bucket to catch them in. And you just want to set it on a part of the sky, probably not near the radiant where the streaks are small, but maybe at about a 90-degree angle. Also consider the rule of 500. If you set up a camera on a time exposure, you'll get star trails. The rule of 500 says that you can go up to 500 divided by your focal length in seconds without significant trailing. That's for like a standard DSLR with a crop sensor. So for example, with my 20 millimeter lens, 500 over 20 is 25. So I can do 25 seconds and I won't get trailing. But I use a little sky tracker. In part, that's because of the photo I'm going to show you here in a second. So here is my best photo from last year's Perseid shower. This is the Milky Way. There's Altair down there. There's Delphinus right there. And there's a nice Perseid streaking down the Milky Way. I have a Nikon D7100. I was using a 20 millimeter f2.8 lens, which has a field of view of 61 by 43. This was a 20-second exposure at ISO 4000. I didn't want to go much higher because I was afraid of the noise, but I wanted to get as much as I could without sky fog. This is the best exposure of about 2,160 exposures taken over 3 nights. So I did that with my intervalometer. I set the camera up on a sky tracker. I pointed it at the same part of the sky, and I set the intervalometer off to shoot one exposure every 22 seconds, I think, because it needs a second or two to download the photo onto memory and then start again. And so that was 2,160 photos that I had to look through, and a handful, maybe 40 of them had meteors that I could see. But you're probably not going to do that. And well, hang on, let me jump ahead because I was talking about my exposure. So this is the exposure that I came up with. This is a composite exposure I made from those 2,160 exposures. I found the ones with meteors. The one I was showing you is one of these. I think it's that one right there. And then I stacked them in Photoshop. So I had a sky tracker to keep the field centered so that the meteors were actually in the same place. Otherwise, the radiant will drift. And the base photo was a stack of several at a lower ISO to have a less noisy photo. And then I took the meteor photos and I put them in on top of that. And then in Photoshop, you make a mask and you make the entire mask opaque, except for you erase it over top of the meteor so the meteor shows through. And of course, those meteor photos, I went in and I ramped up the contrast to bring out the meteor. And so, yeah, there's a little bit of hocus pocus going on here, but this is a reasonable representation of what you'd see with the sky. Not everybody in astrophotography does that. This is, in fact, a gap. For some reason, the shower just decided not to have any meteors in this area over 3 nights. And you notice there are some meteors that aren't following the group here. They are sporadic meteors. Like that one is probably an Alpha Capricornid down there. I think that one's probably a Delta Aquarid. Those might be sporadics. You know, occasionally I catch satellites and I got to go, all right, is that a satellite or is that a meteor? Usually I look for the signature that it starts off dim, gets brighter, and gets dimmer again. So this is what you can do with a lot of work and a lot of photos and a subscription to Photoshop. But maybe you want to try your smartphone. And here I don't have a lot of experience, except that I have a smartphone. I've been able to take pictures of the stars with just setting it down on a table and holding it steady. But you probably want to do something a little bit steadier than that. So you need a time exposure. You need to be able to focus at infinity. Some cameras have a pro mode, but I've looked for that in my iPhone. I've never figured that out. So it probably means you're going to purchase an app. So this, I have, it's in the next one. I have, I have Nightcap for camera. It has an app that has down here under the types, it has a meteor photography. And what it does is you push the button, you put it steady, you push the button. So I push the button, lay it on a table with the lens pointed up, and it just repeatedly takes pictures. And I think it saves them when it sees a streak. And then it saves that photo for you. So that's one way to get some photos. And if you're lucky, maybe you'll get something really good. And maybe there's better stuff out there, better apps. I haven't done my homework on that. Okay. So time to wrap up. What's coming up? Well, I've already mentioned the Perseid shower. And unfortunately, that's your best bet for about the next 6 months because the Orionids are mooned, the Leonids are mooned, the Geminids are mooned. The Quadrantrids will be okay. That's January 2nd to 3rd. You got to really, it's going to be cold out if it's clear. But remember, it also has a very brief peak, so you got to figure out where it's going to be. The Perseids will be good this year. We will have a little bit of moon, but the moon sets around midnight or maybe a little bit after. And so the peak is predicted August 11th to 12th this year, but you can probably see a good number of meteors on the night of 11th, 12th, and 12th, 13th. And so after moonset, things should be good. If you want to get info, go to American Meteor Society, www.amsmeteors.org. They're a reliable source of information. So is the International Meteor Organization, the IMO. They both have lists of meteors. They both have information. Be careful with the media. So I got this in a text a couple of days ago. This is from the Houston Chronicle. And I don't know who Ariana Garcia is, but she probably has never attended an astronomy club meeting because, how to see this month's rare double meteor shower. The meteor showers may even coincide with the active Perseids. The story was about the Alpha Capricornids. Remember, you might see 1 or 2 an hour. And the and the Delta Aquarids. And remember, you might see a handful an hour. It's the Perseids that are the main show. And yes, they will overlap, but it's the main show is the Perseids. And no, you're not going to see this. And so there's a grain of truth in there, but darn it, it's, they're all after the clicks. And so you really got to be careful about listening to the media. All right. So I'm done. Let me answer questions if you've got them.
All right. Hey, Will, thank you. That was really good. Just a quick comment before I dig into the questions. I do a little bit of night photography. It sounds like the same principles you apply for night photography apply here as well. I did
Correct.
notice, though, you were using a camera tracker so that you were staying on that one piece of the sky where you expect the meteors to emanate from. But other than that, there's a lot of
Right.
similarity.
Yeah, Chris, the only reason I used a meteor tracker was that so the stars would stay the same. If you just want to get a bright streak, then it doesn't matter. Just a regular old tripod, or even just setting up your camera on a beanbag or something, just so it's steady and take time exposures. Like I said, I use the intervalometer on mine, so just repeatedly shoot photos without me having to touch it, and that way I'm not messing with it when I'm trying to record the meteors. But everything about taking a astrophoto works exactly the same. You just want a wide angle lens so you can have a big bucket.
Gotcha. Excellent. Well, let me go through the chat here. To start out with, Heather Charon says, "Happy National Women's Astronomers Day." So, happy National Women's Astronomy Day. That's a wonderful day. I didn't know that. I didn't know we had one of those, but that's great.
This is Heather. I didn't either, but then I saw it on Astrobin.
Okay, excellent. Well, good, good. I'm glad you put it in the chat. Brooke Marshall says, "Great presentation. Maybe a little discussion on which showers are north versus southern hemisphere." Brooke, do you want to come off of mute and add to that, or did I get it right?
Yeah. So I saw he had a post
Yeah, actually, that's a
that
good.
showed the different showers, and I didn't know if they were all northern based.
Most of the info that you're going to find is Northern Hemisphere. Both the AMS and the IMO are Northern Hemisphere focused. It all depends on, you can get a pretty good idea by just figuring out where is the radiant, and then take a star app and find out how high does a radiant get. If the radiant gets 45 degrees or higher, you're probably got a pretty good shower. And so, some showers are better than others. The Perseids are pretty far north, so you're probably not going to see it very well in the southern hemisphere. You'll see some, but you won't see as many. The Geminids are fairly far north, but I think the Eta Aquarids is Aquarius is pretty far south, so that's a good shower in the southern hemisphere. But check the IMO and the AMS for that kind of information.
While I'm thinking about it, yeah, thank you, Brooke. While I'm thinking about it, will the Perseids be better to view at a more northern latitude than where we are here in Houston? So, for example, if I went up to Alberta or New York, or, well, not really. I mean, in a light polluted area, but is generally you're going to see. Are you going to have a better show if you're farther north?
Yeah, it depends on the shower and the radiant. Like the Perseids are where the radiant probably transits about 45 degrees, something like that, because it's almost circumpolar. So if you go north, that'll be a better shower. The closer you get to the zenith, the more meteors you're going to see.
All right, thank you. Going along here, Madison Hanks asked, "Did I miss the gear or technique to photo mentor section?" Madison, could you come off mute? Did Will answer that for you during his presentation? Are you there, Madison? I don't think Madison's either he's on mute or can't hear me. In any
Yes,
event,
I'm sorry.
oh
I'm
yeah,
here.
yes.
Trying to take care of children.
Oh,
I'm
okay.
sorry, I missed it. What was
No,
what I got called?
you had asked, did I miss the gear or technique to photo mentor section?
Oh,
And I had replied that I think
yes,
that
that
yeah,
was
it
a
was
good bit
coming up.
earlier.
Yeah.
So
Did he answer the questions you were after on that?
unless I missed it, was what if we only have a cooled camera? What do we do then?
So,
Is it
sorry,
the technique
Madison,
still the
what
same?
kind
If
of
all we
camera? Oh, cooled. Okay.
yeah, like the standard what is it? 533 is what's the new hotness, or I don't know. I'm still new to this. Like, but just a standard ZWO cooled camera. I know you can strap on a wider angle DSLR lens with some sort of converter. Is it still the same technique of 30 seconds or?
Yeah, so I would experiment with that. I don't know what ISO that, ISO is a term familiar with DSLRs. It should work. If you can put a lens on it and you can get a time exposure, everything you've done with it on other astrophotography will work just the same. I would say you have to experiment to see how fast is your sky going to fog up, and that'll determine how fast your exposure, how many seconds to make your exposure.
Okay, Victor Venturini asks, I will be right on the equator near Quito, Ecuador in August. Will I be able to see the showers, meaning the Perseid showers?
So yes, you will, but the radiant will not get high in the sky, so you won't see as many as you would if you were farther north. It's inverse of your question, Chris. If you go north, you'll see a better shower. The best shower is when the radiant is exactly overhead, and when you get down to the equator, you should be able to see the radiant, but it's going to be probably 20 degrees off the horizon or something like that.
Victor,
Thank you.
did that answer your question?
I'm going to have to go to a place where I could see a 20-degree horizon. So thank you very much.
Yeah,
All right.
but it's partly horizon, but it's also, you're seeing meteors everywhere. So imagine your radiant is on the horizon. You're missing half the meteors that are going the other way, right? That are below the horizon. But it's also has to do with the meteors are not evenly distributed. They're more around the radiant. So, as the radiant gets higher in the sky, it gets better. You will see some meteors from there, especially if you go to a really dark place.
Will Young states, I've got a great video of the Perseids from a few years ago. Was there anything more there, Will, that you wanted to comment on or ask?
I've never done a video. I know people do that. One way to make a video that I've seen done is you just take a series of individual exposures and then you put them together in a video. And so you see the stars drift and you see bright streaks suddenly pop up. But you could also try to make a video. And I think Walt was on here. I think that's what Walt and some others in the club have video stations that take videos of meteors. Walt, I see Walt popped up. Walt, you want to comment on that?
Yeah, we have 6 stations with a bunch of basically inexpensive security video cameras in each of the stations that look up in the sky, and they just shoot the sky all night long and break it up into 8-second video clips, and then in the morning the computer goes through all the video clips and looks for meteors, and if you got the same meteor from 2 different stations, 20, 30, 40 miles apart, then you can actually get exactly what that path of the meteor was. You can measure the brightness, everything else. And so that gets reported to the astronomer at the SETI Institute out in California, and somewhat more than 2 million meteors have gone through that system in the last 12 or 13 years. Peter Yeniskins is his name. Was this more than you asked? And he just came out with a book detailing the 2 million meteors, basically. And right now, they've certified over 500 meteor showers as a result. But many of those are little meteor showers that they're not the kinds of meteor showers you're talking about, Will, where you go somewhere and get to watch great meteor showers. So anyhow, yeah, those are little video camera systems, and you can Google CAMS, CAMS, and Meteor, and it'll take you to the webpage.
Excellent. Thank you, Walt. Will Young, did you have anything to add to that, or did you get what you wanted out of the discussion? Will Young going once, going twice. Go on to Heather Charon. She says Photo Pills is a great app to help with astrophotography and other tools. Do you have any experience with that, Will Sager?
I've got it. I've got it on my phone. I'm too busy to use it. I haven't tried it.
Okay, but it's out there. I know that there are some real aficionados of that software. So Walt had a comment. So rare it only happens every year at the same time. Walt, I don't understand that.
Sorry, well, that was just a comment when Will was talking about the 2 meteor showers. How rare! What an amazing thing in the Chronicle article that, wow, 2 meteor showers overlapping. And of course, it's the same 2 meteor showers that overlap in the exact same way every year. So
Gotcha.
I was really just amplifying what Will said is, yeah, this was someone who had no earthly clue what they were talking about. But
Understood.
it was an article in the Chronicle.
Gotcha. Peggy Mueller asks, not sure if I missed this, but what causes the various colors of meteorites? Peggy, did you want to come off mute and expand on that?
Oh, I've heard people say that they've seen beautiful colors and heard, noises from meteorites. So I was just curious, are the colors from the elements, or are they the elements in the atmosphere, or the elements in the meteorite, or what? That's all.
Yeah, so you're exactly right. As they go incandescent, they burn off the material, and it depends on what the material is you're seeing. The color depends on the elements that are being burned, and I'm not a chemist, so I'm sorry, I can't tell you about that. Yes, some people hear showers. You got to have a big meteor for that to happen. And I've never heard a noise from one, but I know some other observers had.
Thank you. Thank you.
All right.
And then, of course, there was that one, the Chelyabinsk meteor in Russia, that the sound was loud enough that it actually just rained destruction on the ground.
Well, we don't want that. Not in Kingwood anyway. Just a little astronomical joke there. Heather comments that the new Move Shoot Move is a star tracker that's less than $300. So again, if you want to add that to your portfolio of photography equipment, that would be one to look at. Walt, you had commented that the meteor color depends on the composition of the meteor, which I think was in response to Peggy's earlier comment, I'm assuming. Madison had the question about the ZWO 533, which we talked about. Marcus Mitchell, is there a DSLR you would recommend for photographing meteors, maybe a $500 or below model? Marcus Mitchell, did you want to come off mute, amplify on that at all? Will, did you have any input on that?
So, I have a Nikon just because I've been a Nikon fanboy for, 30 years or more, something like that. All you need is a good DSLR. You probably want one, and many of them have this now, have a menu that will allow you to do things like the intervalometer is a nice thing. Has a screen that where you can blow up your image so you can get a good focus. Then it's pretty much whatever one you can find. And you don't need to go out and buy the newest and the greatest. I have my Nikon D7100s are like 10 years old, and I got one of them was a used body I got from KEH Camera for maybe $300, something like that.
Gotcha. And then Heather had supplied a model number of a camera she used in response to that. Chris Minion asks, can you do a time lapse of Perseid meteor showers? Chris, did you have anything to add to that? Chris Minion. So Chris is either tied up or can't find her unmute button.
I'll answer that.
Yeah, go right ahead.
You're taking time exposures, and the duration of each meteor is typically a fraction of a second. And so it's only going to be on one frame. So you can make a video in which you stack all of the photos that you take, and you'll see the stars drift, and every now and again you'll see a meteor flash, but it's flashing on one frame. So you've got to adjust your frame rate so that it's not going too fast, but you can make a time lapse.
The Lightcap app has a dedicated time lapse, I was told.
I think you're right, but I haven't tried it.
And you can also use Auto Stacker to separate all your frames after you do it as well. Like if you're doing lucky imaging, that kind of thing. It's a free software, so it works really well.
Did that answer your question, Chris?
Yes. Thank you, sir.
Great. Thank you. Madison Hanks asks, is there a bad level of zoom on a DSLR lens? I only have a 70 to 200. Is this too much zoom to even bother? Will?
Yeah, that's a bit much. I think you could use a zoom lens, like your standard kit lens on a DSLR usually starts around 18 millimeters, something like that, which is 35 millimeter equivalent to about 25 or something like that, 26. You could use that. 70 is a bit narrow. You might catch something and maybe you'll get a good photo. I tend not to use zoom lenses for astrophotography just because they're not as well corrected as other lenses, but you could certainly use one.
Yeah, I concur. I think the wider the better, in my opinion. Chris Shumate or Shumate, I can never tell if I'm pronouncing that correctly. He asks, have you ever tried to use any of the very low power wide sky binoculars in the 1 to 3 by 50 millimeter range? Perhaps these might help in the more light polluted areas of Houston. I've used these for scanning or sky scanning. I'm sure the better strategy remains eyes only. Any comments on that, Will?
Yeah, sure. So that's an interesting thing. I mean, sometimes people see telescopic meteors. You're just lucky you look in your scope, one goes across. Likewise, binoculars. The issue is you're narrowing your field of view. Now, the ones you mentioned, those wide angle binoculars have a fairly wide field. You're going to miss a lot of meteors, but when you see one, you're going to see it better. So that is one thing that's positive about it. I don't know how much it helps light pollution, maybe a little bit because you're more focused on it. But like I said, when I go meteor observing, many of the meteors I see are way out at my peripheral vision. So you won't see those. You won't even probably see the ones that are kind of halfway up. You're looking at a narrow area. So that's a trade-off. You might see a nice meteor that way, and it might be very rewarding.
Chris, anything to add to that?
No, Chris, that was a good answer. And, I love my binoculars, as you may know from prior conversations. And I'll play with it a little bit. I think I'm going to try it out with the upcoming shower on the 12th, just to see if I'll bat a little bit here. But thank you very much. Nice presentation.
Thank you. Don Anderson comments that Comet's high iron appears yellow, high calcium purple. Green is due to oxygen and nitrogen atoms in the planet's atmosphere. And I think that was in response to the question about the chemical composition. So thank you for that information, Don. Appreciate that. Will Young, I didn't have a question, was just throwing it out there that video on meteors is possible. Okay, so I think that had to do with taking a video. Joe Califf, you can hear the meteors if you're tuned into an AM radio station at times. Really? Joe, tell us more about that.
Yeah, if you've got, and I don't know the specific frequencies or anything, I think the frequencies are broad enough that if you have an AM radio and it's on as a meteor strikes through the sky, I don't know the exact physics of it, but you'll actually hear static, kind of crackle through the radio speakers there. And I've heard from some people, they said that they like doing that because it kind of helps them confirm, even if they've missed one, by looking at it, that they, had one kind of enter the atmosphere in a different direction than they were looking.
Yeah. So actually, Joe, one of the things I've heard about is there used to be, the AMS had a radio meteor group. And so what they would do is they're ham radio operators. And when a meteor would streak through, it ionizes the upper atmosphere. And so that's a reflector. And so it would enhance the signal. I think one of the things you can do was to record like an airport repeater from a distance. And when you get a meteor, it would ramp up. It would, give a brief burst of sound.
Interesting.
Yeah, and I can add a little something to that too. They're using similar methods actually to identify daytime meteor showers, which there are some. Sometimes the radiant is is close to the sun. It's in our daytime, no matter where you are. And so they've used techniques like that, and there are a number of daytime meteor showers known just because of that kind of work, which is pretty dang cool, I think.
So I can get into radio astronomy using my car radio. How about that? Okay, very cool, very interesting stuff. Joyce Alma Guire Riesdorf, and I probably butchered that last name. This is a little off topic since we're not likely to see meteors, but everyone at all levels is welcome to the Clay Eastern Glades in Memorial Park on Saturday, August 17th to enjoy the evening and see what we can see. So thank you for that information, Joyce. Appreciate that. Let's see what else we've got. I think we're kind of at the end of the chat questions, and we've gone over on time, but I'll open it up if anybody has any questions that they just thought of and wants to come off mute and ask. We'll take one or two, and then we'll shut it down for the evening. So anybody have any final burning questions that they'd like to ask Will?
Hey, this is Bill Spazzeri. I hope this is okay. I don't have a question, but I'm just compelled to say that I did hear a meteor once. In the early 1980s in northern Wisconsin, I was out looking at the Perseids, and in the 80s, it was very dark up there. And all of a sudden, this thing came roaring through Delphinus, and I could hear it like a loud hissing or whooshing sound. And it left the trail for 10 minutes. But I was jumping up and down and yelling and screaming for, I think, longer than that. And my mother had just come out of the building and said, "Oh, is that what you're out here to see? That's really nice." And I said, "No, Mom, you don't get it. That never happens." We were both just extraordinarily fortunate to see that. Again, the trail lasted at least 10 minutes. And so that was extraordinary. Every million years you get to see one.
Wow. Well, thanks for sharing.
if I can follow up with Bill, Amelia and I both have heard one or two meteors, probably out of Columbus site years ago. Don't remember when or when it was, but we did hear them. And also, I want to bring up about point meteors. Aren't those meteors that coming directly at us?
Yes.
Yeah, every now and again, I'm looking at a meteor. I see a flash, and it's like, okay, there are other things that flash, but meteors. But that is one thing. It could be a meteor coming straight at you.
And they're too fast to duck your head and have it miss you.
Any other questions before we sign off? Going once, going twice. Okay, listen, before we break off, let me just mention tomorrow's meeting, the general meeting is at 7:00, and the presentation will be entitled Mediocre in parentheses, Almost Successful Astrophotography with our own Bill Spizzirri. So if you can make tomorrow's meeting, please do. Bill's a wonderful speaker and always gives entertaining topics. Will, I want to thank you very much for tonight's topic.
Thanks, everyone.
Was wonderful, and I hope everybody has a good rest of your evening, and take care.